All right, so in this example, we're going to investigate raster functions within ArcGIS Pro, which offer a pretty efficient way to work with and process and visualize raster data. And as a specific example, we're going to look at calculating the normalized burn ratio and then the difference normalized burn ratio to assess the severity of a forest fire. So this image here is showing the extent of a fire. Actually, let me turn this off. This is the extent of the fire. You can see there in kind of the darker tones, and this is before the fire. So these are specifically Landsat 8 OLI data, or Operational Land Imager data. This one from April 2015 predates the fire, and this one from April of 2017 occurred after the fire. So this is specifically the sand fire, which occurred in the Angeles National Forest just east of Los Angeles on July 22nd, 2016, which is obviously between these two dates. All right, so before we actually get into the analysis, I'm going to quickly conceptualize this index so you kind of understand what we're trying to do. All right, so this website is EarthLab, which is a good resource for people that want to do remote sensing work with an environmental context. So in this specific example explains how to do the difference normalized burn ratio. So this is the ratio. So it's the near infrared minus the shortwave infrared divided by the sum. So this is similar to a normalized difference index like in dnBR. So why is this specific ratio useful for trying to differentiate types of or burned areas from not burned areas? So that's explained pretty well by just simply looking at some spectral reflectance curves. All right, so this is the spectral reflectance curve for kind of standard vegetation. So this is the visible spectrum, so we don't see much reflectance in the blue range or the red range. Again, that's associated with the photosynthetic pigments in the plant. We see a little bit more reflection in the green range. That's why plants appear green to us. Then in the near-R range, we see a lot more reflectance. Again, and we commonly say in remote sensing, if we could see near-infrared, that plants would look near-infrared, not green. But we can't see that, so that obviously doesn't really mean anything. So in short, lots of near-IR reflectance there. And then out here in the shortwave IR, we've got some reduced reflectance and some absorption features associated with water in the plant tissue. So that's your typical vegetation reflectance curve, which would be like like a forested pixel. And then this represents the curve for like bare soil or a burned area. So we see low reflectance in the visible ranges, reduced reflectance in the near orbit ramping up, and then more reflectance in the shortwave in comparison to the vegetation. So in short, vegetation is going to have a high near IR reflection and a lower shortwave IR reflection, and burned areas are going to be the opposite. So we have high shortwave reflection, low or high shortwave reflections for the burned area in comparison to more absorption there for the vegetation. So that those two bands should be able to differentiate burned and not burned areas pretty well. And then to actually see change, we can just simply take that ratio from before the fire and subtract from it the ratio from after the fire, and that's the difference normalized burn ratio. So we're actually going to implement this a couple of different ways in Arc, using regular geoprocessing tools and then looking at raster functions. Okay, so back in Arc, we have our data loaded in. So I have the two images read in as a multi-band stack and symbolized as a standard false color, where red represents near R, green represents red, and blue represents green. So red areas are showing high near R reflectance, so that's a signature of vegetation. And then I also just pulled in the raw bands that we need to work with. So I have the band 7 and band 5, which is shortwave 2, and the near R band for both the pre and post. Okay, so I've already created a model builder tool that does this. So I'm going to look at that first. We're not actually going to create it. We're just going to look at it so you can get a sense of how this is done. And as a note, there are multiple ways you could go about doing this. So if you wanted to implement this in model builder, you might come up with a slightly different solution to the problem. Okay, so basically I have a model here. And again, if you're not familiar with model builder, blue circles or ellipses indicate inputs. Green ellipses indicate outputs, both intermediate and final. The yellow rounded rectangles indicate processing tools. If there's a P next to it, that means I've set that up to be a parameter in the model, so a user could define that. And if you got this little drop shadow behind everything, that means that that process has been run or that output has already been generated. So I've actually run this tool already. So let's look at what's actually going on here. So first I found that these data weren't really playing well in the model because they were being treated as integer data as opposed to float. So I've converted the data to float measurements. So basically we can maintain decimal points. So that's what's going on here. And then that output gets pushed into a minus or a plus. So basically we subtract the near and the shortwave IR here. So that's the near R minus the shortwave IR. So that gives us the numerator for the ratio, and then we add them together to get the denominator of the ratio. Then we take the difference and divide by the sum, and that gives us our pre or post. So effectively this chain of events up to here creates the pre-fire in normalized burn ratio, and then this is the same chain of events but applied to the post-fire data. And then both of those get fed into another minus operation. So we take the pre and we subtract from it the post, and that gives us the difference. And then in order to actually display it, instead of just using the index, we do a classification. So in this specific example, I'm setting anything less than 0.1 to 1, which is basically in this case going to mean not burned. 0.1 to 0.27 would be low severity, 0.27 to 0.66 is medium, and anything above 0.6 is 4. Note that the range is not this wide, but I set the negative value, the lowest value, and the highest value high, just to make sure it incorporates the full data range. So what this model should eventually spit out then is simply a reclassified raster grid of not burned, and then 3 levels of burn severity. Okay, so again, I'm just gonna do if I do a validate there, the drop shadows go away, and we could rerun it. Note that I made parameters, so that means that I could actually run this like any tool. So I'm gonna go into this catalog view, and then go into toolboxes, this toolbox, and it's this model. So if I click on it, it opens up over here as a tool. So you can input your data, and then you get the dnBR as an output, which is the continuous measure. I'm just going to put a 2 on the end since I already ran that, and we'll make it. We'll leave it as that. And then we get out the class one. So we'll call that also, we'll put a 2 on the end of that. So we should be able to run this tool like any other geoprocessing tool once we've created it with Model Builder. So let's hit run there. And here you can see, I'm just going to expand this. It's going through all of those steps, and you can see it executing there. So while this is running, we're going to talk about some of the issues with this. So whenever you do traditional geoprocessing using tools from the toolbox in ArcGIS Pro, you're actually generally writing a file to disk. So it could be a file that goes into a file geodatabase, or some type of flat file on disk, like an image or a TIFF file for a raster, or like a shapefile for a vector. So that tends to slow the process down a bit. So if you work with raster data a lot, and you work with large data sets like images or elevation services, it's not uncommon to let things run overnight or run for a couple days to get your output, and you can generate some, again, fairly large data sets, in the orders of hundreds of gigabytes. So if you need to actually save out your data, that's kind of necessary. Oh, looks like we're done. So let's go back to the map here. Okay, so here we have our output. So real quick, I'm just going to show you that output. We'll make everything that wasn't burned see-through, and then we'll just use increasingly darker shades of red to differentiate the fires. Okay, so let's zoom out here. So this is our extent. That was the range. We'll turn that off. So again, if we zoom in here to the sand fire, we should be able to see that scar, and it looks like our dnBR lines up with that, or sorry, dnBR lines up with that pretty well, right? And we can see some high severity areas there in the dark red, and some moderate and some low. And then there's some random noise out here that may or may not be fires. These extents down here probably are other fires, I mean that they're that large. So that works perfectly fine. Like, it gives us an output, it's written to disk. Now we could do something else with it, like make a map or try to gauge the different area of like moderate versus severely burned areas. But if you wanted to speed this process up, and especially if you only need to use the data within ArcGIS, you don't need to export it, or you just need to simply visualize the output, another way you could implement this process is using what's known as raster functions. So if you go to the Analysis tab, you will see links to your different analysis tools. We can open up the toolbox, we can open up Python editor, change our environment. Some of the really common tools are listed here for like vector and raster data. What we're looking at now is these things called raster functions. So I'm going to open up one of these real quick, and we're going to run it so you can kind of see what it does. So as you can see, there's a bunch of tools in here. So we have some analysis tools, appearance tools like doing a stretch. There's tools in here for doing image classification, like doing calculating image objects using machine learning classification. There's tools in here for creating hydrologic surfaces like flow accumulation, flow direction, delineating watershed boundaries. We've got our reclassify, generating surfaces like hillshades, slope surfaces. So these are tools that you're used to seeing in the toolbox. There are some of them go by slightly different name, and there are some tools that aren't in the toolbox. So, for example, there's a lot more convolution options in here than there are in the toolbox for doing things like, you can see all the options here. So, if we're doing things like smoothing and edge detection and sharpening and whatnot. Okay, so let's just run one of these. Let's just run one of these. So I'm going to do this in dBI. And we're going to grab an input. So let's just do our post-fire. So grab our post-fire image. And the visible band in this case wants to be our red band, which is the band 4. And our infrared band is going to be band 5. And then I'm just going to hit create new layer. Okay, so this spits out a NDVI surface. Again, let's just compare this to the image. We turn this off. I'm gonna turn off the burn output, so we can see there a reduction in the NDVI index over that area. So this ran really fast, as you can see. It basically was instantaneous. So actually, what's going on with these raster functions is they're not actually writing permanent files out to disk and running your entire extent or data set. Instead, it's basically running the data virtually or running the analysis virtually and storing the output in memory, and also only does it over the area that you are currently displaying or viewing. So what does this mean? Well, effectively, it's just raster analysis kind of in memory or on the fly. So this allows you to do things like make very complex calculations quickly just for, say, visualization purposes. So there are some drawbacks. One issue is that this is a virtual output, so it doesn't actually exist. So if we wanted to actually produce this output, then to use like in another piece of software or something, we would have to go over here and export it out, which is going to require you to actually save the data, which could take a long time. But if you just want to do some analyses all within ArcGIS, this can be a much more efficient and faster way to work, especially if you have very, very large data sets. Okay, so to finish this up then, let's implement this exact same process, but we're going to do it now with the raster functions as opposed to doing it with our standard geoprocessing tools within a model builder setup. Okay, so let's see if we have this dnBR, or sorry, normalized burn ratio. See if anything pops up. So we don't see anything there. That's because there's not a dnBR tool built into these functions or provided as a function that I am aware of. So what that means is we actually have to generate something custom to use. And that's what this function editor is for. So let's open that up and see what it looks like. Okay, so when this opens up, it looks kind of similar to the model builder tool, right? But it actually is a separate set of tools. And when you're working in this environment, you should actually be using these raster functions as opposed to geoprocessing tools. In fact, I don't think it would even let you pull that in. So let's just try real quick and see. I'm just going to grab like a clip. Yeah, well, didn't add it. So see that we basically can't use those tools. We have to use our raster function tools. So let's go back to that tab. Okay, so to implement this process, I'm going to need a couple different inputs, and we're going to do it slightly different because there's some different tools available here. So first thing, I want to add some variables. So I want to have a raster layer and another raster layer. So this is going to be our pre and post fire imagery. And then we want to actually do the math or calculations. So to do that, we can use this, I believe it's called band math, band arithmetic. There we go. So we can build out the ratio in there. Oh, I guess I need two of those. Let's just grab another one. Pull that up there, pull that up there. And then we want to do a subtraction to get the difference once we have those as an output. So we'll do a minus here. Oop. Pull that over. So subtract them out. And then we want to do a reclassify, which we can use a tool called remap here in the raster functions. And then lastly, we want to define the display settings. So to do that, we'll use this attribute table tool. Okay, so let's drop that in. All right, so there we go. We've got our basic process, our tools and inputs that we need, but I haven't actually set anything up. So our next step is going to be to actually set some stuff up. All right, so what we're going to do here is set this, that's output. We're going to make that the input here of that arithmetic, and then the other image would be that input. Both of them are going to go into the minus. This is going to go into the remap, which is basically reclassify, and then that'll go into the attribute table. All right, and now we want to look at some properties. So I'm going to go in here to variables. So we have one image coming in. I'm going to call this we'll just call it pre_fire. And we'll put public, that way others could use it if it was like published. Or set it, I guess. And then we'll go to properties again for this one, and we're going to call this one post fire. And we'll make that public. Okay, so those should be our two data sets, or our two, setting our two input rasters. I'm going to rename this. We're going to call it pre-fire. And then this one we'll call post-fire. It's generally good to do this, try to use names that actually are interpretable if you can. Especially if you're going to make this tool for someone else to use. Okay, and then in the minus here, we shouldn't need to change anything there. In the remap, we definitely want to set that. So we want to set up our same, move this over here. We're going to set up our same breaks that we had for the other, the model builder output. So we'll do anything low up to negative 0.1, and that's going to get output as 1, and then we're going to do our actually this should be 2.1, and then we'll do 0.1 up to 0.27. We'll code that out to 2. Then we'll do 0.27 up to 0.66, and we'll call that 3, so that's your moderate. And then our last one will be 0.66 to a high value, so I'm just going to put in 1,000. Make sure we cover the whole range, and 4. Okay, so 0.1, negative 1,000 to 0.1 goes to 1, 0.1 to 0.27 goes to 2, 0.27 to 0.663, 0.66 to 1004. And that should output that. And then we want to specify an attribute table. So we're going to go to manual here. And we're going to have four values. We'll have 1, 2, 3, 4. And we can assign names. So we'll do not burned. I'm just running them together because I'm not sure if you can use spaces. Low, moderate, and high. And then we can set default colors for the class display. So we'll make that transparent, and then we'll do our deeper shades of red for our different levels of burn severity. Okay, so that's that. Now let's go into our band arithmetic, and we can specify this. So there's no in dnBR that I've noticed in here, so we're going to do this as user defined, and we just basically want to set up our math there. So this is going to be band, let's see here, band 5 minus band 7 divided by band 5 plus band 7. And then we'll do the same thing here. Properties. So we want to do, again, band 7 minus band 5 minus band 7 divided by band 5 plus band 7. All right, and then we got an input coming in, so we should be good there. And one other thing we can do is set a default. I don't think we need to do this, but I'm just going to go ahead and do that. So we're going to set our pre-fire image as a default image. So if the user doesn't set one, it'll just go to this image. And then our post-fire image, which is the second one. Did I put post for both? I feel like I did. Set default. Post. Okay, so our post image goes in. We do our band math. We do a subtraction, we do a remap, and we do an attribute table so we can kind of define our own symbols. Okay, so that's that. Now let's do a couple other odds and ends. One thing that I've noticed with this is you got to be careful about the inputs. So we go to general. This is going to come in. That should be fine. 32 output, pixel type. Yeah, those will be 32-bit float out. Again, we want to make sure we maintain our decimals. This we want to change to, again, 32-bit float. The remap, that should spit out, since now we're going to be a categorical, we'll do that as an 8-bit unsigned. And then we want our attribute table to accept an 8-bit unsigned input. Okay, so now let's save that. So when you save this, you got a couple different options. First, I'm just going to name it here. So this is different, dnBR, example, let's call it that. You can save it to the project or to the custom, and I believe custom means you can use it outside of the project. So we're just gonna leave it in custom. If there's subcategories, you can assign that, but I don't have anything set up. And we got to give it a description, so I'm just gonna say calculates in dnBR from pre and post fire multi-spectral data. And you can put in some help and whatnot, some keywords. If you're going to use this, probably a good idea, but I'm not going to. You can even put in like a thumbnail for it there. Okay, I'm going to hit OK. And now that should be saved. So now I'm going to go, let me see here, let me get rid of this. All right, so I'm going to open up this custom one. You can see I did this a few other times. There's our dnBR example. So I'm going to open that up. And we have two parameters here, which I specified in the tool. So your pre-fire image and your post-fire image, and they're already set to the defaults, which should be fine. So if I did this correctly and I run it, it should work. So let's see what happens. Oh, it failed. So let's see what I did wrong. Let's see what we got here. Bind failed and function table incompatible pixel types. Okay, so that has something to do with the input pixel types. So let's have a look at that. All right, so this is going to spit out a 32-bit float. That's going to spit out a 32-bit float. This is going to spit out 32-bit float, so those should be fine. And then the remap, go to general here, 8-bit unsigned. I'm just going to swap it over to signed and see if that makes a difference. And then general, we'll just swap this over again to signed. Okay. All right, let's see if that'll process. I guess I gotta go back to my raster functions here. So I did a save. I'm gonna close out of this and open it back up just to make sure it's updated. Should be fine. All right. Let's hit create new layer and see what happens. Nope, same issue. What step is it failing on? Build arithmetic. I was looking at the wrong one. So let's see what these images are. So maybe I had the input type wrong. So raster information. It's 16-bit, I guess. So do properties, variable, parameter, general. Well, that should be okay. Variable, parameter, variable. No, that should be fine. Let's have a look at this. Oh, I see. I didn't change this to user defined. I think that was probably the issue. So let's see if that fixed it. Let me go back to the raster functions here. dnBR. Okay, that's a good sign. Okay, there it went. So you can see it basically produced this layer instantaneously. Again, it's just doing this virtually in memory as opposed to actually writing out the output to disk. Okay, so if we zoom in here, we can see that our output should be effectively the same. Turn this off. This one. So it's the exact same output, basically. You might see some subtle differences if you zoom in based on how it does its like raster overlay and whatnot. All right, so in summary, if you will do a lot of raster processing, you need to just work with your data inside of ArcGIS Pro. You're not going to need to export stuff. You can use these raster functions to create virtual rasters. You can even create your own processing chains using the function editor, and that can actually be very useful for speeding up your workflows and analyses. So if you haven't really worked with this at all, I'd highly recommend giving it a shot and seeing if it can help you out.